Hello students. In the previous videos, we discussed about the electron migration effects, all applications of inductive effect. Now in this video, I will explain the mesomeric effect and its applications also. Now in this mesomeric effect. So what is the meaning of mesomeric effect? So generally the mesomeric effect is also, it is an example of which one? Permanent effect. The permanent effect means here majorly the lone pair of electrons or the pi bonded electrons involving in the conjugation system. So how to explain the mesomeric effect means the delocalization here polarity only develops majorly. The polarity developed due to delocalization of delocalization of lone pair of electrons means non-bonded electrons and pi bonded electrons with a conjugated system. In a given molecule. So this is called mesomeric effect. Okay. So generally what happens here? Polarity develops. So polarity develops in main reason is delocalization of which electron? One is a lone pair or pi bonded electron with a conjugated system. So those are called here mesomeric effects only. So these mesomeric effect again classified into two categories. So mesomeric effect is classified into two categories. One is plus M or plus R. Another one is minus M or minus R. So what is the meaning here? Mesomeric effect is also called resonance effect. So that's why I wrote here plus or minus or conditions. So separately we will discuss that's resonance, one other topic also. So now first one is plus M. The plus M or plus R is also called electron releasing group. Here minus M or minus R is nothing but electron withdrawing groups. Okay, electron releasing group. Here electron withdrawing groups. So now the first one is plus M effect. So in this plus M effect, so what is the condition here majorly? Here delocalization of which electrons? Lone pair of electrons. Simply remember the polarity developed due to the polarity developed same as like definition due to lone pair electrons and negative charge. Negative charge. So if these two involving in the reaction, those are called plus M groups. Those are all called plus M groups only. So next, another one is minus M. Minus M only. So what is the main condition here? Minus M. Here also polarity developed due to multiple bonds due to multiple bonds only. So if multiple bonds involving in the given molecule, those groups are called minus M groups. That minus M is nothing but here electron withdrawing groups. Here plus M is nothing but electron releasing groups only. So in these two cases, so examples of the plus M and minus M groups we will discuss now. So that examples, if you know that examples, we can easily identify the whether that given molecule plus M group or minus M group. Okay, then plus M order. No need to remember the order, just examples enough. Plus M groups. Example, NH2, a lone pair of electron. NHR, again lone pair of electron is present. NR2, OH, OR, so SH, SR. Next, OCOR, NHCOR, they are also one lone pair. Next, another condition here, fluorine, chlorine, bromine, iodine. So here, a halogen family, each one has three lone pair of electrons. In the above cases, nitrogen has only one lone pair. The remaining oxygen, sulfur conditions has two lone pair of electrons. So if these groups directly attach it to the any conjugated system, so those conjugated systems are called here plus M groups. Okay, if conjugated system attached to these groups, these all groups are act as a plus M groups. That means donate the lone pair of electrons. So not only that, if NH minus is attached to that negative charge or O minus is attached to that same group, now these groups also act as a plus M groups only. Next, another one is next minus M groups. Minus M groups. So examples of the minus M group. So that means multiple bonds means if more than one bond is present, those all are the multiple bonds only. Generally, we know that C double bond OH aldehyde it is. Next C double bond OR ketone. C double bond O related groups. C double bond OH carboxylic acid. C double bond OCl acid halide. C double bond OR ester. C double bond O NH2 amide. Next C triple bond N cyanide group. Next N double bond with this is NO2 group only. Next SO3H sulfonic acid group. So etc. These all are the examples of the minus M group. So that means if the multiple bonds involving in the given conditions, so those all are multiple bonds minus M groups. If these groups all are act as a minus M electron with the join groups. Four cases here NH2, NHR, NR2SH. These all groups are belongs to plus M groups. So if you know the plus M and minus M groups, the difference, we can easily identify the which group is influencing in the given molecule. either plus m or minus m. So we can easily say that plus m and minus m groups conditions. So before going to that, we will discuss now conjugated systems. Okay, conjugated systems. Conjugated systems. Okay, so these conjugated systems now. First one, suppose in the given condition CH2 double bond CH CH double bond CH2 given. Now in this given condition, so this one is an example of a pi. It is also another pi bond. Okay, this kind of conjugated system is pi bond system. Pi bond system only. It is also one pi bond. Here also one pi bond. So this is the one pi system. Next, second example is suppose like this given CH2 double bond CHCl given. Now each chlorine has 3 lone pair of electrons. So each chlorine 3 lone pair of electrons. Now this one also lone pair of electron donate electrons to this one. So this is also another one. Lone pair pi bond system. Lone pair pi bond conjugated system. Next, third one. CH2 minus CH double bond CH2. Now in this case also, here the carbon has a negative charge. Now this one donate the electrons to pi system. These electrons moving towards to adjacent carbon. Now it is another kind of system, negative charge pi bond. Negative charge pi bond system. This is also another kind of system only. Next, another examples. Fourth one, CH3 CH minus CH2 plus given. So that time here also the negative charge is donate electrons to positive charged carbon atom. So this is also one kind of conjugated system. Now here in this case we can write a negative to positive system. This is also one kind of conjugated system. Next, fifth one, CH3 okay, in this case CH3 O CH2 plus given a lone pair of electron on the oxygen. So it can donate easily lone pair of electron to positively charged one. So it is lone pair of electron to positive system, positive charge system. So like this also we can say that. And another one, sixth one, this H2 plus. That means here empty d orbitals are present. Now this pi system donate electrons to this. Here pi bond d orbital. In the above case, positive charge means here empty p orbitals. Here empty d orbitals. So that is the difference. So these all are the groups only. So these all are the conjugated systems. So by using this, how to identify the plus m and minus m groups present in a given molecules. So now we will discuss the general examples of mesomeric effect. General examples. In this first one, first identifying this mesomeric, whether mesomeric effect present or not. So how to identify that condition here majorly? Here only one pi bond only present. One pi bond present means there is no transfer of electron or polarity developed in this case. Now it is not a mesomeric compound. Next, another one. CH3, CH double bond CH2 given. So in this case, CH3, CH double bond CH2 present means here also, so there is no delocalization of a lone pair of electron or a negative charge or pi bond. Only one pi bond is present. Here also, mesomeric effect is not possible. Then one more example. Now, here one pi bond is also present. Here also one pi bond. It is an example of pi bond system. So here mesomeric effect is present. It exhibits the mesomeric effect. Next, conjugation must. Conjugation alternatively present. It is only one single bond. There is single bond between the two pi bonds. So that's why here mesomeric effect is exist. Next, one more example, CH3 CHO molecule. Here one pi bond only present between the oxygen and carbon, but there is no other negative charge or if any other kind of conjugated system. So here also mesomeric effect is not possible. So we can say by using this directly. Then next, another condition, CH2 double bond CH C double bond OH. Now here one pi bond, here also another bond. So this is the multiple bond only. Now this group alone, just identify this group. Now that group alone it is minus M group. Why? Because these pi bonded electrons moving towards to this carbonyl group. So multiple bonds are involving in the conjugation. Here minus M effect is possible. It is very, very important. Next, another one. CH3, CH2, Cl. Chlorine has a lone pair of electron, but here there is no another conjugated system. There is no delocalization. Here, mesomeric effect is not possible. Next, another example. CH2 double bond CH Cl given. Here also lone pair of electrons present. Then the lone pair of electron is this chlorine is donate the electron to adjacent carbon atom. Now these pi bonded electron moving towards this carbon. Now here lone pair of electron involving in the conjugated system is called plus M. Now this chlorine it acts as a plus M group only. So plus mesomeric effect is present. Next, another one. CH2 double bond CH CH2 Cl. Here like this given. Here if you observe in this given case also, a lone pair of electron present on the chlorine, but here how many sigma bonds present in between the chlorine and pi bond? Two sigma bonds. If two sigma bonds present, here there is no conjugation. So this compound does not exhibit the mesomeric effect. Next, another example. Next example is CH2 double bond CH2 plus. This one. Here empty p orbital, here pi bond. This pi bond donates the electrons to carbon. Here also this group acts as a plus M group only. This one donates the electrons. So this group alone it acts as a plus M. Next, another one. Here negative charge donates the electron. Here this one comes to adjacent carbon atom. So here also plus M group is present. This group alone it acts as a plus M. It is also conjugative system and here possible. The next another example. O minus. Suppose here instead of this circle now I am writing double bonds, alternative double bonds. If this O minus donated electron, these electrons comes to here. That means here also delocalization possible. Now this group alone it acts as a plus M group to donate the electrons to system. Next, another one RO minus. In this case, there is no conjugation, so here mesomeric effect is not possible. Next, one more example. RC double bond O minus. So in this case, how to identify that given conditions, whether given conditions are here negative charge donate the carbon, these electrons moving towards to this oxygen atom. So now here also this one acts as a plus M group only, plus M group. Next, another one. So like this. Here this chlorine donate the electrons to this, these electrons moving towards to this. Here also again chlorine acts as a plus M group only, plus M group. Again nitrogen donate the electrons. Here also this group acts as plus M group. Next. C double bond O CH3. So now in this group, system only donate the electrons to this C double bond O group. This group alone it acts as a minus M group. So mesomeric effect is present. The next another one. Here double bond. Here lone pair of electron alternatively present. This donate electron, this one moves towards to that side. So here also this nitrogen group acts as a plus M group, plus M. Here one double bond, here lone pair. It is non-alternatively present. Here there is no mesomeric effect condition. This one. In this case also, oxygen has a lone pair of electron. It donates electrons to this. This comes to here. Now this group alone it acts as a plus M group only. Next. There are two sigma bonds present in between them. There is no conjugation. Here also there is no mesomeric effect. Next, another one. Here also alternatively present. Now, if it is donate electrons to this comes to here. Now this C double bond O group alone acts as a minus M group. Minus M group. Next, another example. Like this given. Non-alternatively present. Here also mesomeric effect is not possible. Then one more example. In this case, there is no double bond is present, so there is no conjugation. So mesomeric effect is absent. Okay, by using this, we can identify the whether mesomeric effect is present or not. Okay, so these are the examples to identify the mesomeric effect, whether it is a plus M or minus M. But sometimes we can identify the inductive effect also in this given compounds, that both comparison only we will discuss now. Comparison between mesomeric effect and inductive effect. If you know this identification, whether given molecule is mesomeric or inductive, so based on that we can easily solve the all problems. Okay, next one is CH2 double bond CH CH2 O CH3 group given. So in this given compound, the oxygen has a lone pair of electron, but lone pair of electron and this double bond, two sigma bonds exist in between the sigma end. This is the one sigma bond, this is the another sigma bond. So is there any delocalization? No delocalization. No delocalization means mesomeric effect is absent. So now this OCH3 group alone, it acts as a minus I. So in this given example, minus I only present. We can say that one directly. Okay. Next, another example, CH2 double bond CHO CH3, like this given. Here also oxygen has two lone pair of electrons. Now, if you identify how many sigma bonds present in between the double bond and a lone pair of electron, only one. So now this lone pair of electron easily donates to this compound. Now here these pi bonded electrons moving towards to adjacent carbon atom. So that time this group alone it acts as a plus M group. So identifying this very important. The difference between the OCH3 groups, here it acts as a minus I. Why? Because there is no delocalization. But in this case, delocalization is possible here. Here these electrons here moving towards to this double bonded carbon atom. So that's why here this group alone it acts as a plus M. This OCH3 group acts as a plus M group. Next, same as like one more example. Here positive charge. Here positive charge. Like this rings only given. Ring. Now each oxygen has a two lone pair of electron. Like this. In these two, so which one is plus I, which one is minus I, which one is M groups means first group, here there is no contact in between the positive charge of the carbon and lone pair of electron. That means Now this OR group is directly, this is nothing but OR group. Here also these are the OR groups only. Now it is OR means it acts as a minus I. But in this case, here OR group donate the electrons to adjacent carbocation. Adjacently, if any positive charge is present, it acts as a electron donor. Electron donor means it is a plus M group. Here this group is acts as a plus M. So the difference in between them, it is very, very important. If instead of that, another compound given, suppose CH2 double bonds NH2 group given, it has lone pair of electron. Next, same as like CH2 double bond CH, CH2 NH2 group is given. Now NH2 group also in this case, it acts like, here there is no alternative. Okay, two sigma bonds present, no delocalization. No delocalization means here this group alone, NH2 group alone acts as a minus I group. But in this case, it donate electrons to adjacent to double bonded carbon atom. Now this group alone, it acts as a plus M. So these are the differences in between the plus M and minus I. So what are the groups present in this majorly? I will give the example here. OH, OR, NH2, NHR, NR2. These groups all, if these groups are directly attached to the any conjugated system, first which group influence? Less M influence more. Next only minus I group. We should take the M and inductive effect based on these conditions. If these groups directly attach to the conjugated systems, that time these are act as a plus M. Otherwise, minus I groups only. So this is a very, very important plus M minus I conditions. Then the next video we will discuss other the important stability of the benzyl carbocations and allyl carbocations. So please share and subscribe my channel. So watch the videos and share to your friends. Thank you.